design. And you'll find different books that break up the process of solution design into different types of design. Functional design, which is a term that I use, and I don't actually see it in the literature that much, but for me, a functional design is a detailed description of how, for software that involves a significant component of user interaction, how the user will interact with the software, what the software will do in response to each action that the user takes. It's kind of a behavioral description. It's somewhere between a problem definition and a design, because it doesn't say anything about the internals, but it is nevertheless a design process because you make a lot of decisions. There are lots of different ways that you can structure an interactive application. So I tend to use this term. Architectural design has to do with the larger components of the system as a whole and how they're going to be distributed to different processors or to different, in different environments. It's more of a serious issue in a large client-server or distributed system than it would be in an embedded system. But even in an embedded system, you have questions such as, what will I put in read-only memory versus what will I put in rewritable memory, and so on. Implementation is usually called either implementation or coding. But in fact, implementation can mean much more than coding. If you have a system, for example, that has a database component, this can include creating the scripts that will produce the schema for the database. In other words, deciding what the structure of the database will be and controlling that. Populating the database with new data, maybe converting data from an old system to a new system. That would all fall into the implementation phase. Solution validation, depending on your perspective, and there's excellent chapter on validation in this book, I think. It can either be looked at as testing, which is once you're done, does it do what I think it should do, or does it have bugs? Or it can be looked at an earlier stage as program or really design verification. It really depends on what aspect of the solution you're validating. Deployment is sometimes called integration or release. And the usual terms that one hears for solution evolution are maintenance or enhancements. So when you see these more traditional terms, I hope that by the end of this course you'll think in terms of the activity names that we've adopted, or at least understand that these are not points in time or linear. It's not a linear sequence. It's very interactive. Any questions on that? Because we're going to shift in sort of a different direction now. Early in the lecture, Kurt was talking about the notion that software development is really an art, and that the function of software engineering is to move it from being an art to a discipline, something that's controllable and predictable. And I agree with that 100%. Nevertheless, software development continues to be a creative process that requires intelligence. It requires the ability to make judgments. It requires the ability to both analyze situations and synthesize solutions. So break things down and then draw conclusions once you've broken things down. And these are things that only people can do, at least so far. So both the literature and my own experience convince me that in a software project, success depends at least as much on the people involved as on any particular technique or tool or process. And why is that? Well, there's a variety of reasons, but one is that software engineering processes have to be executed by people. They don't exist in a vacuum. And they can be executed well, or they can be executed badly. Just as an example, one common process that I would consider part of software engineering is to establish coding standards. Are you familiar with coding standards? Has anybody ever mentioned coding standards to you? Coding standards are basically an agreement by everyone on a team that you're going to write your code in a particular way. For example, if you're using C, you're going to use a particular convention for naming your variables. You're going to put a particular kind of comment at the head of every function. You're going to use a particular style of indenting, and that's one where you get a lot of disagreement. The point of having coding standards is so that everyone's code on a team looks more or less similar, and so that I can go and look at someone else's code and not be hindered by minor formatting issues, that I can focus on trying to understand the code without having to go into my editor and change all their braces so that instead of being at the end of a line, they're at the beginning of the next line, which, believe me, I will do. If someone hands me some C code that has what they call the, this kind of structure, I'll always move it so that the braces line up, because I can't understand particularly if it's a heavily indented structure, what opening brace goes with one closing brace. So the purpose of coding standards is and we'll talk more about coding standards later, but it's an example of a process, a software engineering process. Now, if upper management comes along and says, you're going to use these coding standards, and the developers say, well, I don't like these coding standards. I want to write the code my way, and they don't use them, well, you might as well not have that software engineering process, because you're not going to get the benefit from it. And that's really true of every software engineering process. It requires what's called buy-in. Everyone on the team has to agree to participate. And the fact of the matter is that people are not going to participate unless they can see why a particular process is going to help. So if you don't understand why coding standards would be useful, you're not going to use them. The other reason that the success depends on people is because there's so much communication that's involved in a software development project. No one person can know everything about a complex software system. So you have to be able to ask questions. You have to be able to express your design in a way that someone else can understand. And there's also the question of individual knowledge and skill. I mean, someone who has been writing software for 15 years, in general, is going to write better software than someone who has only been writing software for a year. So people are very, very important. And we're going to talk a lot more about that in the graduate software project management course than we are here, because the focus of this course is on the developer, on the individual team member. But nevertheless, you should keep in mind that no amount of process, no number of tools is ever going to solve your problem or help you gain control of your software development process without people being committed. And it's a really critical word. The company and the team and the individuals all have to be committed to using software engineering. And that's why sometimes you only can use a little bit of structure. It may be that you need to start with only sort of minimal rigor, because that's all people will accept when you start. As Kurt pointed out, we come from an industry perspective. We have been out there working for a lot of different companies. We've seen a lot of failed software projects, many more failed software projects than successful software projects, in my experience, and I suspect the same is for Kurt. And if you did a survey, I think you would still find